This lesson is to introduce you to the metric system. Most of you have already been using the metric system for years. I'm going to show you conversion from one unit to another, probably in a different way than you've been shown before. We're going to use dimensional analysis that we used in the unit conversion. So the objective of this lesson is when we're done, you'll be able to use dimensional analysis to convert from one metric unit to another. That means that I actually want to see the work. I don't want to just see a decimal point moved. So please, when you're doing these, show them like the examples that we do here in the lesson. Now, what I have here is a chart that has all of the prefixes in it that we're going to use and more. We start out with a base unit. This can either be meters or grams or liters. Then going bigger than the base unit, we have deca. Then we have hecto. Then we have kilo. Then we skip two spots that we don't really need the names for, and we go to mega. We skip two more spots, and we go to giga. These are very common in using computer storage. Now, smaller than the base unit, we have the deci, centi, milli. We can skip two places because we don't need to know the names for those. You will need to know micro, and then two more places, and you will need to know nano. The symbols for each of these: giga is a capital G, mega is a capital M, kilo is a small k, hecto is an H, deca is actually usually a DK because we need just the D for deci. Then we have C for centa, little m for milli. So we've used capital M and little m. We don't have anything left in the English system that looks like an M. So we use the Greek letter M, which is mu. It almost looks like a U with a tail on it, but it really is the Greek M. And then we can use an N for nano. Now, for our first example, let's do one that should be fairly simple. Let's deal with centimeters and meters. So let's go back and look at that chart. Notice that centa is two places away from the base unit. So when we come back over here, I'm going to look at centimeters and meters. The easiest way to do this is to always put the 1 on the bigger unit. And since meters was to the right in that table, it's the bigger unit. Sorry, to the left. Now, it was two places, so this should be 10 squared. The power of 10 will always be how many places you need to move it. And if you have put the 1 on the larger unit, you'll always have a positive exponent and you don't have to worry about negatives. So now, let's start our problem. And my conversion factors from this equality would be 10 squared centimeters to a meter, or 1 meter to 10 squared centimeters. So we'll start with what we were given, and we were given centimeters. So just like in the unit conversion lesson, since I want centimeters to go away, I need to have the one that we start with from the problem put on the top here, and then the one we're going to use to cancel out on bottom. So that means I need centimeters over meters. So centimeters will be gone. I have 45 to start with because that's what's in the problem. And then 1 meter to 10 squared centimeters. So when I do this problem on the calculator, that's going to end up giving me meters for my final answer. So we have 45 divided by 100. And notice that that gives me 0.45. So I know a lot of you have always been taught to just move the decimal point 2 places, and yes, that is what ends up happening, but because of the problems we're going to be doing in here this year, the unit conversion will actually help you in the middle of a problem rather than having to sit there and try to figure out how to move the decimal point in the middle of a problem. So this is the way I'd like you to try to work all of these. All right, let's try another example. This time we're going from meters to millimeters. So let's go back and look at the chart. Meters is going to be here where the blue base unit is, and we need to go to millimeters, so that's 3 places. So we're going to have a 10 cubed in our equivalence. So if we put the 1 on the bigger unit, which is always the one on the left, then we know that it's a positive exponent when we take the smaller one, and you don't ever have to worry about a negative. But again, you've got to put the 1 on the bigger unit. So that means my conversions would be 1 meter to 10 cubed millimeters, or 10 cubed millimeters to 1 meter. So let's see which one we need. So to start the problem, whoops, I probably should go on and draw my line. So we're going to start with meters, so that's what's going to be right there, which means I have to have meters down here so that they cancel out, which means I need the millimeters up here. So that tells me then that I'm going to be using this conversion factor. So let's put the numbers in. So we have 2.1 meters, and 1 meter is 10 cubed. And if we just multiply that, since meters are gone, I'll have my final answer of millimeters. So let's pull out the calculator, and it's 2.1 times 10 cubed, which is 1,000. And so I get 2,100. Again, I still only need the 2 sig figs, so my answer will be 2,100 millimeters.